we know this is an odd degree polynomial. Odd degree polynomial. And what's the degree? We can count. We can count the wiggles. We have one wiggle, so basically we have this point. We have these turning points. We have 1, 2, 3, 4 turning points. So we know this is odd degree 5. Right? This is odd degree 3 because we have odd degree 3. And this is odd degree 3. With an even degree polynomial, we have either upward, looks like our both hands raising up, right? We have this kind of graph. So this is even degree polynomial with the leading term positive. If the leading term negative, we have this kind. You know, both hands going downward. Leading term negative, even degree polynomial. So we're at this stage. And we want to see when the function value to be 0. So which means those points, right? You see those points, the y value are 0. So we call those points zeros or roots, right? Because we set this because the function value to be 0, we solve for the roots. So at this stage, okay. So Tijeka wants to show 21. The Sarah 27. Let me make you presenters. All right. So if you are ready, show us. Okay, Jeremy 31. Yeah. So get yourself ready, all right?
Okay. Good morning. So I'm presenting question 21, section 3.7.
Okay.
So it's Rx equals 5 over x minus 2. To find the vertical asymptote, take the denominator, set it equal to 0, and then I solve for x. In this case, x is equal to 2, which is the vertical asymptote. And now to find the horizontal asymptote, since there is no leading term for the numerator, and the denominator is a becomes a heavy because it's x to the first power, so therefore the horizontal asymptote y equals. I try to graph it until one of my classmates clarified it to me. That's it.
Okay. So for this question, we're finding vertical asymptotes.
The vertical and yeah.
And the horizontal asymptotes. All right,
Yes.
instead of finding vertical asymptotes, you to set the denominator to be 0, solve for x, great. So x equals to 2, that's your red line.
Yes.
Red vertical line is your vertical asymptotes. For horizontal asymptotes, we're saying take the leading terms. Okay, let me ask you, Tijeta, what is the leading term for the numerator?
For power.
It's a 5, right? It's just a
For
5.
Say that again.
The leading term
Can you
for the numerator.
Yes, go ahead.
Right, the leading term. What is the leading term for the numerator?
So over here, since it's only 5, doesn't mean that 5 is the leading term?
Right, that's right. That means the 5 is the leading term. So
it will be 5 over x?
Right, will be 5 over x.
Okay.
Yeah. Now think about x goes to infinity.
Mm-hmm.
If x goes to infinity, what's 5 divided by 5 apples shared by the whole wide world population? How much apple can each person get?
Can you repeat that?
Okay, so now you're taking leading term of the numerator, which is 5.
Yes.
The leading term for the denominator, which is x. So now think about
Yes.
x goes, x is an infinity.
Yes.
So what's x divided by 5 then?
Any number that is greater than 5? I'm not really sure.
Right, okay. All right, so how do you get what? So your conclusion is your horizontal asymptote is y equals to 0, right?
Yeah.
Which is the right answer. How did you come up with this answer?
Because I thought the 5 was not the leading term. I thought the leading term have to be x to something power. That's why.
Oh, okay. So this is 5. 5 is, so you have 5 divided by x, right? Take
Mm-hmm.
the leading term. Let me type in the chat. Take the leading term, you have 5 divided by x. Now think x goes to infinity. Positive infinity and negative infinity. What's the 5 divided by infinity?
It could be any number since it's infinity.
Infinity is an idea. Think of 5 apples shared by all people in the world.
5.
Okay. So now, we want to find out horizontal asymptote, right? Horizontal asymptote
Yes.
is taking the leading term of the numerator and denominator. So the leading term in the numerator is 5. Leading term in the denominator is x. So now we're left with 5 divided by x. So what do we go from there to find horizontal asymptotes? We think about x goes to infinity and negative infinity, right? So if x
So
goes to infinity,
can x be any number but not 5?
x is a very, 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 very big number. Infinity means it's a huge number. We cannot even think about it.
Yeah.
Okay. So now we have to think 5 divided by infinity, right?
Mm-hmm.
So how do we think about 5 divided by infinity? Think about a life situation like this. We have 5 apples shared by all people in the world. So how much apple each person can get? Little, right? Almost nothing, right?
Yeah, since it's infinity, it's like, and it's only 5, so people will barely get anything.
Yeah, that's how you get y equals 0. You see that?
Mm-hmm. Yeah.
Okay, so x or 5 divided by infinity equals 0. Also, 5
Yeah.
divided by negative infinity will be negative 0. Well, negative 0 is still
Yeah.
0. So that's
It's
how
still
you
0.
get y equals 0.
Okay.
Okay, all right,
I
thank you.
understand that. Thank
Okay,
you.
thank you, Sujata. Let's see, James, 27. Okay, Ola wants to put present 25. Let me make you guys presenters. Yeah, just choose a number from homework 5. Okay, right, get yourself ready. So Liz want to present also. Yes, Sarah, if you're ready, go ahead.
Can you hear me?
Yeah.
So I'm presenting homework 6, question 27. So I wrote out the steps here. I don't know if you guys can see that. So the first step is to factor out x, and then rewrite negative x as 2x minus 3x. So you can split it, and then from there you're able to group the terms. And once you do that, you have to factor out x minus 3 to get this equation, and then from there you need to get your zeros. So you had to set everything up to equal 0. So x minus x equals 0, x minus 3 equals 0, x plus 2 equals 0. And then from there you get your 3 different x values. I picked 0 to plug into the equation here to get y equals 0. And then from there, I plotted these 3 different x values with their y's. And that's it.
Okay, let's see. Right. So you find your 3 roots. And then let's see. Right, Sarah, it looks good, but let me ask you 2 questions. So P of 0 equals 0 gives you the y-intercept, right? Which also happens to be the x-intercept. And also, the function is a polynomial of degree 3. Right? And also the coefficient, the leading term is positive. That's why you graph this way, right?
Yes, I guess.
Yes, otherwise, how do you come up with this graph? Because this is degree 3 polynomial. Degree 3 is the odd degree of polynomial with one hand up, one hand down. And the leading term is positive, so you have your right hand up, left hand down, right? Imagine this side is the right hand. This one, right? This goes downward. Okay, that's great. But you have to be able to explain to me. All right. Thank you, Sarah.
Thank you.
If anybody has any question, just ask. Okay, who else is ready? Okay, Jeremy. Okay, go ahead.
Remove mine. How do I take it out?
Okay, whose work is this?
This is mine.
Go ahead, Ola.
Okay. So number 25.
Okay.
To find the vertical asymptote, x equals 1/2. So what I did for the vertical asymptote is set x equal find the s of 0, right? So you basically plot in 0 for wherever you have x. And then I got a -1, which means x equals -1 is like the vertical asymptote. And then for the horizontal asymptotes, what I did was the leading coefficient for the two wait, what's it called? Yeah, 6. The leading coefficients like I labeled here, 6 divided by 2. So 6 divided by 2 is 3, and that gives us the horizontal asymptote.
Okay, Ola. Right. The second one, horizontal asymptotes, we take the leading term, not only the coefficient. But in this case, you did it right because the both leading term is x squared term. We took x squared divided by 3x squared, so x squared divided by x squared becomes 1. Not only the leading coefficient. All right, for the vertical asymptotes, what do we do? We take the denominator, we set to 0, right?
Yeah.
Okay. So can you explain more about how you did that? How
Just
did you find the vertical
when you
asymptote?
have x, you put 0 in it, and boom, you find your answer.
No, you put 0 for
I
that's
cannot
the
explain is the
step.
problem. That's why I'm not just. It's just like set s, like just what I wrote here, s of 0. So yeah.
That's your y-intercept. So this is plug into 0 for x value. That's called a y-intercept. Make sense? Because your x value is 0, then in this case your y value is -1. This point we call y-intercept.
Yeah.
Right? To find vertical asymptote is to take the denominator, then set to be 0. That would be too small to write. You take a 3x squared plus x minus 1, you set to be 0.
And that gives us -1.
Huh?
I said that gives -1.
Let me write in the chat. So
I
you
get
take
what
the
you mean.
denominator, your denominator is 3x squared plus x minus 1 to be 0, right? This is how we find vertical asymptotes. Then this is a quadratic equation. How do we solve this quadratic equation? This one we have to use the formula. We have to use either completing squares or quadratic formula. Do you see the problem? So by plugging 0 for x, that's to find the y-intercept. That's not to find vertical asymptotes.
So that's wrong?
It's not right.
Okay.
Your s of 0 is the y-intercept. So to find vertical asymptotes, we take the denominator, we set to
Actually,
0. Hold on a second.
The x's with 0 and get -1. Just ignore whatever is on the top. I mean,
Okay, hold on, Ola. Is the denominator 2x squared or 3x squared?
it's 2x squared. So if you put
Oh, it's 2x squared, not 3x
a
squared.
-1.
2x squared. Okay, your answer here actually are right. Because when you factor it, you factor as 2x plus
So you can
1.
just put -1 on the top of it. Like put in 0 in this, you get -1, and x is gonna equal -1. And then if you put in 0, I don't know.
No, then how do you get a half then? X equals a half.
So at the beginning, I just said just ignore x. X equals -1.
No. Ola, your answer is right. Your answer is right. Okay, let me
Yes, I don't
close it.
understand. Copy the steps as I see it based on whatever question it fits in the textbook, and I just do whatever I do.
Okay, so that's 2x squared plus x minus 1 to be 0. Okay, does this step make sense for you? This is how we find vertical asymptotes. We set the denominator to be 0. So the denominator here is 2x squared plus x minus 1. We set it to be 0. Now, can you tell me how to solve this quadratic equation? 2x squared plus 1 minus plus x minus 1 equals 0?
What? What did you say?
I said, now, can you tell me in the chat? Can you see my chat?
Oh yeah.
2x minus 1 equals 0?
a second. So all you gotta do is use the quadratic formula and put in the. So the first step you're gonna do is the quadratic formula, which is negative b plus or minus the square of b squared minus 4ac over 2a. So in that case, a equals 2, b equals 1, and c equals negative 1. Can I write? No, I don't know how to do that.
Well, you can factor it, right?
Yeah, so wait, I think I figured out to write. There we go. Oh, but that's hard. So can I just explain, because I can't write it. I don't know how to write it with the blackboard thing.
That's okay. You can look in the chat. We can factor in this case.
Okay, so basically 2, b equals 1, and c equals negative 1 based on the equation, right? And then you plug in, and it's gonna give you like x equals negative 1 plus or minus the square root of 1 squared, right? Yeah, minus 4 times 2 times negative 1.
Yeah, you can do that.
Then divided by 2 times 2. The quadratic formula. And then you simplify that, and your solution is x equals 1 over 2 and x equals 1, negative 1. Yeah. I can't write it because I don't know how to use this whole thing.
That's okay.
Yeah.
But there's a simple way. If you can factor it, it'll be faster. Yeah.
Oh, you can do that. Formula.
Yeah, that's okay. That's okay. Yeah, so you're gonna have a. So that's how you get a vertical asymptotes.
Yeah.
So your answer is right. You get 2 vertical asymptotes. One is at the value x equals half. Another one is x value equals negative 1. All right. Thank you. Next one. Yeah, go ahead.
Am I the presenter now?
Oh, I did not make you present. Oh, yes, I'm sorry. Okay, go ahead.
Okay. For I have like some trouble now.
Do you have
Extra application screen, right?
that's right.
Extra application. Okay, here it is. Do you see it?
No, oh, it's coming up. Yes.
Okay, so I did 31. And basically what I did, it is dx equals to x to the 4 minus 3x cubed plus 2x squared. And basically what I did was I factored it out to get negative 2x plus 2 on one side, and then to negative 2 and x minus 1. And then I was able to what is it called when
Put in the
you take
factor form.
yes. And that way I was able to get, I put x and minus 2 together, and that way I got x minus 1, x minus 2, and then I found my zeros. which is at the end I got x equals to 1 and x equals to 2.
You're losing one root. You're losing one. Do you see which one you're losing?
Is it the x squared?
Yeah, x squared. If x squared equals 0, x is 0, right?
Right.
So you're losing
That's right.
one root by 0. 0 has to be one root. You have 3 roots, 0, 1, and 2.
Okay.
So let's see your graph, right? So your graph, right, in your graph, you do graph 0, 0, 1, and 2. Can you
Yes.
explain to us why you graph like this?
Yeah, because it's because of the table.
Oh, okay. One is because of table, or
Yeah.
we can think this way, right? This is a degree 4 polynomial. It's an even degree.
Okay.
Even degree with both. Imagine this is your two hands. I cannot draw here. You see your W-like, right?
Yes.
Think about those W like your two hands. If the leading term is positive, the two hands go above your head. So that's why you have this W, upward W-like. If this leading term were negative, you would
It would
have,
be like upside down.
yeah, you would have like an M-like.
Right.
Right. Okay, great. All right. Thank you, Jeremy.
Sure.
Okay, who's next one? Who is ready?
Me, Professor.
Yeah.
Okay, so sure.
Did I make you a presenter yet? Oh, yes, I did. Okay.
Okay, I'm sorry that I went first, but I said in the chat that I'm ready.
Oh, that's okay. You know, whoever is here, you know, go ahead, explain it.
I'll be real quick. So I did problem 6 from homework number 5, and I made an error on letter D, which is -2 parentheses x plus 2. But okay, so for this one, we just had to sketch the graph by transforming the graph of f of x equals x to the power of to the 4th power. And so this is like the original one, which is f of x equals x to the 4th power. Here it is. And the first one I did was x to the 4th power minus 16, and here it is. So we can see that the x-intercept for this one is here. So we have 2, 0, which is here, and then we have -2, 0, and the y-intercept is 0, -16. For the for the b, let me see, this one right here, we can see that the x-intercept is -2, 0, and the y-intercept is when it touches the white line here, 0, 16. And for C is this one. Wait, let me see. Yeah, this one. Sorry that the graphing is like not.
No, it looks beautiful.
It's not. Yeah, because like these graphs, since is to the 4th power, it's like this is like flatter than just a regular parabola. So I try to do it as good as I could, but
Looks great. Looks good. Yeah.
okay. So this one is the RX here, which is C. And the x-intercept is 0, 0 and -4, 0, and the y-intercept is 0, 0 since it doesn't touch the y line here. Okay, and then for D, which is the one that I made the error, this is actually supposed to be like up here, and the x-intercept is -2, 0, and the y-intercept is 0, -32 when this line touches the graph later on. I cannot portray it because I just put the numbers of the graph until 16. So like I didn't have enough space, but that's it. This is like shift up instead of shift down. Yeah, that's it.
Okay, let me just ask you. The graph
Mhm.
looks beautiful. Okay,
Okay.
let me just ask you D, right?
Mhm.
D is a transformation, right?
Mhm.
So actually, all those functions A, B, C, D are just like you said, the transformation functions of x raised by 4.
Mhm.
So D. So what is the y-intercept for D?
D. Okay, so here it would touch this line would actually touch this line later on the point of 0, negative 32.
Great.
Mhm.
Yes.
I
Yes.
couldn't show it because
Yeah.
I only put negative 16.
Yeah. It's okay. Right. It's
Mhm.
okay. Yeah. Great.
Okay.
That's it.
Thank you.
Right. Thank you. All right. Next one.
I'll do the next one, Professor.
Okay, James. Thank you.
Are you seeing my screen, Professor?
Yeah. Yeah.
Okay. So for number 27, it's finding the vertical asymptote and the horizontal asymptote. For the vertical asymptote, all we need to do is just make the denominators both equal to 0. So for example, x plus 2 equals to 0 and 3x minus 1 equals to 0. So for the vertical asymptote, it would be 2 vertical asymptotes. So it's going to be x is equal to negative 2 and 1 over 3. Finding the horizontal asymptote is finding the leading coefficient for the numerator and denominator. So for the leading coefficient for the numerator, it's going to be 5, and the leading coefficient for the denominator is 3. So the horizontal asymptote is going to be x is equal to 5, y is equal to 5 over 3. So yeah.
Okay, James. Let me ask you.
Oh, sorry.
5. Hold on.
Okay,
Okay. Tell me what's the leading term in the numerator? That's not only 5.
really?
Yeah. The leading term for the numerator is 5x times x.
Hmm.
5 is the coefficient. So the leading term is 5x times x, which is 5x squared.
Oh.
The leading term for the denominator is not only 3, 3 is the coefficient of the leading term. So it's 3x times x, which is 3x squared.
Hmm.
So 5x squared divided by 3x squared, it is 5 over 3, because x squared divided by x squared is 1.
Hmm.
Okay. All right. Okay.
Oh,
All right. Thank you, James.
you're welcome.
All right, great. Anybody else want to show any work? Present your work? Oh, Rina. Yeah.
Yeah.
Yeah, go ahead. Oh, let me make you presenter. Oh, okay. 31. Jeremy did. Maybe you can choose something else. $33, right? I don't think anybody showed 33 yet. Let me make you a presenter. Yes, go ahead.
So for 33, I factored the function, and then I ended up with x squared minus negative 1 and x plus 1. And then I brought down the other x plus 1 because there was 2.
and then I set them to 0. I mean, I put them x plus 1 as a parenthesis because there was 2 of them, and then I set them to 0 to find the x-intercept, and then it's -1 and 1, and then for the y, I plugged in 0 for x, and then I found the y-intercept, which is 0, -1, and then the leading coefficient is x to the third, so it's degree 3, and then I graphed it with the snake thing, and then that's it.
Looks great. And then this is a perfect graph. But let me ask you one question. Why at the -1 it touches it? It does not go through this point.
Oh, because the multiplicity is 2, so
Right.
it has to touch. It doesn't go through.
Yeah, good job. Yeah, we see two factors that being -1. So the multiplicity of the root is 2. So this is just touches it. It just touches the point, not go through the point. Great job. Okay, thank you, Rena. All right, Natalie. Natalie, you ready?
Yes. This morning.
Mm.
Hello.
Yeah, we can hear you.
Okay, I thought my.
Okay, but we don't see your screen yet.
Oh, I haven't shared it yet.
Okay. Ola, what's your concern?
Professor,
Yeah.
can I ask about the grades again? For real, I feel like I need to know exactly. And now I don't know failing or I'm passing or anything, which is kind of, I don't know, maybe bad
Oh,
because I need to know
I think you're
exactly
doing
what I'm
fine.
doing.
You know, according to my memory, I think you are doing fine. You have presented a couple of times. You have sent me your homework. I think you're doing fine.
What if at the end of the semester I end up not doing as fine as I think I'm?
Oh, I don't have a grade for anybody yet. The grades will be in the end of it. It has to consider every element of it. Homework, presentation, final. Okay. I don't have grades for anyone yet. Yeah, just don't worry about it. I think you are doing fine according to my memory. So Natalie, right, I see your work. I see your screen now.
Okay, I'm doing 29 right here. So for vertical asymptote, I took the denominator to 0. So 2x cubed plus 5x squared plus 6x equals 0. And then I factored x out. But then I couldn't solve for this one because there was no factors. So I just did x equals 0, and then I put this there because it has no roots. And then for the vertical asymptote, I just took the leading term, so 6x cubed divided by 2x cubed, and then I got 3.
Okay, let me ask you one question. How do you know the second factor, 2x squared plus 5x plus 6, has no root?
Okay, first because I couldn't solve it, and then I actually did the equation, like I tried solving it somewhere, and it didn't have no root.
You have to show it, right? You have to tell the reason why it has no root. You could use quadratic formula. Remember quadratic formula?
Yeah.
Yeah. So you can do A, B, C. You know, x equals to negative b plus minus square root of b squared minus 4ac, all divided by 2a.
Mm-hmm.
You show that. You could show what's b squared minus 4ac in this case.
Oh, okay.
What is it? Can you do a quick calculation?
B squared minus 4ac.
Right.
Okay, so
We read in the chat. So there's negative b plus minus square root of b squared minus 4ac, all divided by 2a. So this is a quadratic equation. You can always use the quadratic formula. You tell me A, B, C. What is A in this case? What's B? What's C?
A is 2, B
A
is
is
5,
3, B is 5,
and C is 6.
A is 6. Great. We just plug in, right?
Yeah.
So let's plug in B squared minus 4AC. What is that?
So 5 squared minus 4 times 2, 8 times 6.
Right. What do we get?
25 minus 48.
Right. What's the problem over there?
Give us negative answer.
Negative. Right. So what is the square root of negative 23?
Cannot be solved.
Right. Square root of negative 23 has no solution in real numbers. Okay, you have to say this much, right? Square root of negative 23 has no real solution, but a complex solution in real numbers. Then you can conclude there's no real roots for this factor.
Okay.
All right. Okay, thank you, Natalie. Natalie,
No problem.
anybody else? I think that's all for today, right? Okay, anybody has any other questions? Okay, we're going back. So far we're in a polynomial functions. I think by now we probably have a good idea about polynomial functions. So I'm going to skip complex numbers because complex number is not in our syllabus. All right, let's go back to our rational functions, right? Since we know polynomial functions, so go one step further, a rational function. A rational function has a numerator, has a denominator. The numerator is a polynomial, the denominator is another polynomial. That we call rational function because the x term, the variable term, appears in the denominator. So a simple rational function is 1 over x. And let's try to remember the graph. Okay, so this is the graph of 1 over x. Try to memorize this, right? It has two branches. One branch in the first quadrant, and this goes to positive infinity, and this goes to negative infinity. And also another branch in third quadrant. Here goes to negative infinity. Here goes to positive infinity. All right. As x value close to 0 from the left, the function value goes to negative infinity. As x value getting closer to 0 from the right, the function value goes to positive infinity. So in this case, we see x equals to 0 is a vertical asymptotes, right? Remember, how do we find a vertical asymptotes? We take the denominator, we set to 0. So x equals 0 is a vertical asymptotes. And what about horizontal asymptotes? And we see y equals 0 because 1 divided by x. Think about 1, x goes to infinity and negative infinity. One apple shared by the whole wide world of people. So that's nothing. So y equals 0 is a horizontal asymptote. See here, right? Imagine this graph goes on forever, this goes on forever, goes on forever, goes on forever. You see this y-axis has another name. Y-axis is x equals 0, right? All the points on y-axis, x value is 0. So we call this line x equals 0 is a vertical asymptote for the function f of x equals to negative x, well, equals to 1 over x. And similarly, the x-axis has another name, y equals to x. Is a vertical asymptote, right? So let's try to put this graph in our head, all right? Let's try to put this graph in our head. This is 1 over x graph. We have two vertical asymptotes. Y-axis, vertical asymptotes. X-axis, horizontal asymptote for this function. And the domain of this function is x is not 0, right? You see the domain. X can be any value but x, but 0. Then we see these functions a and b. It's a transformation of 1 over x. All right, let's see how. Let's say a we can write in terms of r. So f of x, no, r of x we can write in terms of f. So r of x equals to 2 over x minus 3. We can factor out 2. We can rewrite as 2 times 1 over x minus 3. Now 1 over x minus 3 read as f of x minus 3. Because f is 1 over the input. Right? You see f of x, 1 over x. So f is defined as 1 over the input. The input is x, f is 1 over x. Input is x minus 3, the output is 1 over x minus 3. So we're writing r of x in terms of f of x, all right? 2 of f of x minus 3. If we can write a function in terms of another function, you see that's a transformation. Right? So r of x is a transformation of f of x. So if we can write one function in terms of another function, that is to say the function is a transformation of the other function. Let's see the second one. Maybe we can write s of x in terms of f of x also. So s of x we can rewrite as 3 minus 1 over x plus 2. So how do we get this step? 3x plus 5, we can write as 3x plus 6 minus 1. Because 6 minus 1 is 5. Right? Then we can separate this. We can have 3x plus 6 divided by x plus 2 minus 1 divided by x plus 2. Then 3x plus 6, we can factor out 3. That to be 3 times parentheses x plus 2. Divided by x plus 2, that becomes 3. So we can rewrite this function as 3 minus 1 over x plus 2. 3 minus 1 over x plus 2. And we can rewrite it, switch the order. We can write as negative 1 over x plus 2 plus 3. Right? And then negative 1 over x plus 2, we can write as negative f of x plus 2. Because again, f is defined as 1 over the input. Okay? So 1 over x plus 2, we can write as f of x plus 2. And we see here, s of x is written in terms of f of x. Right? So same conclusion. If we can write one function in terms of another function, that means that function is a transformation of the other function. And if we graph, let's see the graph of this, right? The graph of this, so this we see the transform. How do we see the transformation? First, x value being pushed 3 units to the right, 0 being pushed to 3, so the y-axis being pushed to this dotted line. And the 2, every y value is being scaled by 2. Right? Before we have x 1 over x, we have a graph here, we have one branch there, we have one branch here. Now it's more flat because every y value is being increased by 2. Right? So that's the graph of the first one, r of x. What about s of x? S of x first is a reflection because we have negative f. Right? We have a reflection and the x value is being pushed to the left because this is plus. X value is being pushed to the left. So we have before 1 over x, we have here. Now we see first we have reflection. Reflection means reflect over x-axis. And this branch becomes down. And this branch flaps up. So this one becomes this one becomes this one. That's a reflection. Then x value being pushed to the left 2 units. So 0 is being pushed to negative 2. Then we have this adding 3. That means every y value is being lifted up 3 units. So 0 here before been lifted 3 units up. So 0 is being pushed to the right 2 units, to the left 2 units, and being pushed up 3 units. So this is our new symmetry, right? So we have a graph of this branch, this branch. All right. Asymptotes again. Take the denominator, set to 0. So in this case, x equals to 1 is the vertical asymptote, and the multiplicity is 2. We have 2 of it. And the horizontal asymptotes, we take the leading term. Leading term in the numerator 2x squared. Leading term in the denominator is x squared. So the horizontal asymptote is 2. Y equals to 2. Right here. So the vertical asymptote, x equals 1. So this line has a name. The line of this name is x equals 1. And the horizontal asymptote is this line, and this line has a name. This line is y equals to 2. Right? So this line has a name, y equals to 2. This line has a name, x equals 1. So vertical asymptote is x equals 1. Horizontal asymptote is y equals to 2. So the graph will never pass through these dotted lines. So if we graph that, we get this. So, the vertical asymptotes, the horizontal asymptotes, is basically we can understand as prohibited lines. The graph cannot pass through it. So this is how to find horizontal asymptotes. Leading term of P, leading term of Q. If the same degree, we can take the coefficient. If it's not same degree, we have to take the leading term. Okay. So this, in general, this is not a coefficient, but a term, leading term. Here, right here. Okay. If n equals to m, the horizontal asymptote is just an divided by bm. But if the degree is different, let's see. If the degree of the numerator less than degree of the denominator, horizontal asymptote is y equals 0. As we see before, right, we have 5x. If the leading degree is bigger than the leading degree of the denominator, then there has no horizontal asymptotes. So let me write some examples here. If here we have the leading term, let's say we had a 5x squared divided by 3x squared, right? The x squared divided by x squared equals 1. That's why we only take the coefficient. That's why equal 5 over 3. Because degree are the same. Let's take an example for the first one. We talk about 5 over x. Right? 5 over x. 5 over x. So this, in this case, the degree in the numerator is 0. So 5 is constant function, is a polynomial of 0 degree. X is a polynomial of 1 degree. So the degree in the numerator is less than degree in the denominator. In that case, the horizontal asymptote is y equals 0, right? I said imagine 5 apples shared by infinite many people. So each person gets, almost nothing apple. For C, let's think about maybe we have a 3x divided by 4. Right? The numerator, the leading term, the numerator has a degree 1. Denominator has a degree 0. So the degree in the numerator is bigger than the degree in the denominator. In this case, there's no horizontal asymptotes. Okay, so that means the range is all real numbers. No horizontal asymptotes. So let's see this example again. So find the vertical and the horizontal asymptotes. Right? We know how to do that. Find the vertical asymptotes, we take the denominator, we set to be 0. Right? We factor, put in a factor form. We solve the quadratic by 0 property. So we get a x equals a half, x equals a negative 1. Horizontal asymptotes, we take the leading term, 3x squared divided by 2x squared. That's 3 over 2. Right? Simple and easy. All right, so this is all about rational functions. At this point, we're not going to be so crucial about graphing these rational functions yet. Actually, maybe we should talk a little bit about it. Right? Let's just quickly talk over about this graphing rational functions. Let's follow in those steps. So how do we graph rational functions? Okay, we want to put in a factor form. We want to put the numerator and denominator in a factor form. We want to find the intercepts. Intercept means x-intercepts, y-intercepts, right? So x-intercept. Let's talk about y-intercept, because y-intercept is easier to deal with. Y-intercept is 0 and f of 0, right? Y-intercept. And the x-intercept is the y value is 0. So we set the y value to be 0. And then we try to solve for x. Right? Try to solve for x. So the two intercepts. Then we try to find the vertical asymptotes by taking the denominator to be 0, solve for x. Then we try to find the horizontal asymptotes. Then we sketch the graph. All right. Let's see this one. Let's see example 5. So we put the numerator and denominator into a factor form. So you see how important the factoring skills are. Once we have this, let's try to solve x-intercept. Right? X-intercept means we set this one to be 0. A fraction to be 0, only the numerator to be 0. To solve x-intercept is to set the numerator to be 0. Right? So 2x minus 1 times x plus 4 to be 0. We solve that. We get x equals a half, x equals negative 4. So x-intercepts. Y-intercept, we put x into 0, right? If x is 0, we see we have this factor to be negative 1. This factor is 4. Negative 1 times 4, and the numerator is negative 4. X is 0, we have negative 1. X is 0, we have 2. Negative 1 times 2, we have negative 2. Negative 4 divided by negative 2, we get 2. Right? We get 2. So here, let's see, we get 2 x-intercepts. Get a half, 0 as 1 x-intercept. And the second one, we get negative 4, comma 0. We have 2 x-intercepts and the 1 y-intercept. Y-intercept is a 2, comma 0, 0, comma 2. Right? Okay, we have 3 points now. We have 3 points now. Now let's find the vertical asymptotes. Right? Vertical asymptotes by setting the denominator to be 0. So the factor x minus 1, x plus 2. Then we solve that. So we'll get x equals 1, x equals negative 2. 2 vertical asymptotes. Then we get horizontal asymptotes. We take the leading term. Leading term is 2x times x with 2x squared, x times x squared. So y equals to 2 is the horizontal asymptote. Right here. So leading term of the numerator, leading term of the denominator, we get 2. So this is the y equals to 2. Oh, it's right here. So horizontal asymptote is y equals to 2. Vertical asymptote is x equals to 1, x equals to negative 2. So we put into the graph, we'll have 2 vertical asymptotes, x equals to half, x equals to negative 2. Anybody has a question?
Yes, Professor, I have a question. Can you go up a little bit, please?
Here?
Yeah, over there. Yes. How do you get the vertical asymptote as x equals 1 and x equals negative 2?
Because remember, how do we find the vertical asymptotes? By taking the denominator to be 0?
Yeah.
Right, we have here x minus 1, x plus 2. We set them equal to 0. We solve this. You see we get
Oh,
those
okay, I
two?
got it now. Yeah.
Okay, all right.
All right. Thank you.
You're welcome. So we have x equals a half, x equals negative 2, 2 vertical asymptotes, we put it as a dotted line. And the y equals to 2, we put it as a dotted line. All right? So let me put it over here. So this vertical line has a name as x equals to negative 2, And this one is x equals to half. Those dotted line, those are two vertical asymptotes. And the horizontal asymptotes has a name y equals to 2. Right? So we put it as dotted line. The dotted lines, the asymptotes, it means the graph of the function will never pass the dotted line. And how do we graph the rest of the function? How do we know the function goes this way? We have to give a couple of special points. That's why we have here, right? So we have 2x minus 1, x plus 4, x minus 1, x plus 4, and x plus 2 as factors. Now we can think of this. We can give some special values, right? We can think this one, this factor is negative, this factor is positive, this factor negative, this factor negative. That's one situation, right? Therefore, that will go from negative 2 downwards, right? Think about a negative 3. Think about negative 3. This will be negative, right? This will be positive. Negative 3, this will be negative. This will be negative. So negative. So get the first situation. Then from negative 2 above, right? Think about negative 1. Negative 1, this will be negative. This will be positive. This will be negative. This will be positive. So get the second situation. Then think about a value in between of those two. Maybe 0, right? Because 0, we get 0, we get negative, we get positive, we get negative, we get positive. So we get a 1 negative, 3 positives, as in this situation. Then we think about a value bigger than 1, right? Bigger than 1. Then will be positive, 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 everybody positive. Right? We will have these 4 situations. So why we think like this? Because we have these prohibited lines, right? These prohibited lines give us 1 interval, another interval, 3 intervals. 3 intervals, right? We think about value less than negative 2, value in between of negative 2 and a half, value bigger than half. This is half, right? Oh no, this is 1. Why I get a half? I'm sorry, I made a mistake. Right, this is 1, not a half. I remember something from before. This is 1. X equals 1. Right. So we consider those intervals. Intervals from negative infinity up to negative 2, then from negative 2 up to 1, then from 1 up to positive infinity. We want to consider how the graph behaves in these 3 intervals. Right? So we just pick a value. We just pick a value in the interval. As we can pick, let me put in here. We can pick negative 3. Negative 3 is in the interval less than negative 2. Right? From negative 2 up to 1, we can pick maybe negative 1 in this case. From 1 and above, maybe we can think about 2. Right? So pick some values to see, okay, where is the y value, right? In this interval, from negative 2 down to negative infinity, either the graph is here above this y equals 2, or the graph down below y equals 2. And we evaluate, we see it's negative. Negative times positive times negative, that gives us negative. That means the y value is down here, down below y equals 2. Similarly for this one, right? For these two, then we want to evaluate for this from negative 2 up to 1. Maybe we use 2 values, right? We use negative 1 and a half to evaluate, using negative 1 and a half to evaluate. Then we see, okay, about in between 0 and the negative 2, the function is above x-axis. And then from 0 to 1, the function is below x-axis. So we know the graph goes this way. From 1 up to positive infinity, we see it's always positive. Everything's positive. So everything is positive, that means the graph go above y equals to x. Okay, that's how we graph these rational functions. Rational functions. Any questions? Okay, let's see more. Let's see how do we graph these functions. So the numerator is 5x plus 21. The denominator is x squared plus 10x plus 25. But let's put them in the factor form. So now we can put the denominator is a perfect square, x plus 5 squared. So let's find the x-intercept. So we set this one equal to 0. Right? Then that means 5x. That means the numerator is 0. So 5x plus 21 equals 0. So we solve. We get x equals to negative 21 divided by 5. So our x-intercept, we only have one x-intercept. We get to negative 21 over 5, comma 0. Right? Only one x-intercept, or only one root. And y-intercept, we'll plug in 0 for the variable. So get 21 over 25. So y-intercept is 0, 21 over 25. That's our y-intercept. X-intercept and y-intercept are always a point. Not only one value, it's a point. So we got 2 points on the graph. Now let's figure out vertical asymptotes. Vertical asymptotes by taking the denominator and set to 0, solve for x. So x equals negative 5. Right? So that's our vertical asymptotes. What about our horizontal asymptotes? Horizontal asymptotes, we take the leading term in the numerator, which is 5x, and we take the leading term in the denominator. So leading term in the numerator is 5x, leading term in the denominator is x squared. We simplify this, we get 5x. From our previous experience, we know 5 over x goes to 0. So y equals 0 is our horizontal asymptotes. Then we can graph our vertical asymptotes, right? Our horizontal asymptotes, which is our x-axis, which is y equals 0, have those 2 asymptotes. That means the graph will never passes those asymptotes. Well, now let's find some points, right? We have this, let's put over here. So x equals negative 5. X equals to negative 5 is our vertical asymptotes. So that gives us 2 intervals. So we have an interval. We have an interval from, let's use this table. We have an interval from negative 5 down to negative infinity. Then we have another interval from negative 5 up to positive infinity. So let's plug in some numbers in the interval. Negative 6 will be in the first interval, right? And 0 will be in the second interval, right? From negative 5 up to positive infinity. So 0 will be in this interval. This is from negative 5 down to negative infinity. So negative 6 will be in this interval. So let's put negative 6 in. So 5 times negative 6, negative 30, plus 21, that's negative value. The negative 6 plus 5, that's negative value. But the negative value is squared. So I have negative times negative. So be negative. So the y value is negative. So by doing so, we know the graph is down, is below the y equals 0 asymptotes, horizontal asymptote. So we have y equals 0 as our horizontal asymptotes, right? Because y value, we evaluate one value in this interval. The y value is negative. That means the graph stays down here. Well, let's choose one value, positive value, from negative 5 up to positive infinity. So 0 times 5 is 0, we have 21. And 0 plus 5, that's 5, 5 squared positive, hold on a second, why this is negative? Oh, this is saying from negative value, -5 to 0 maybe. Right, okay. So -5 to 0. Let's still think about -1 maybe. So let's take a -1 for this. Then maybe we'll take another one for 0. From -1 above. So if you take a -1, -1, 5, we still have positive. Negative. So this should be, let's see. So from -1, from -5 up to 0. Okay, so this method won't give us these details. But we can think this way, right? Because these vertical asymptotes means we cannot have x equals -5 in the domain. So maybe we evaluate a value very close to -5, but it's not -5. Maybe let's see, negative 4.9, a little bit bigger than -5. So this value may be a little bit bigger, a little bit smaller than -5. Maybe you can even take a negative 5.1. Right. In this case, let's check. Negative 4.9 times 5 it's a negative number bigger than 21. So that's why we get this negative. Then the denominator will get positive because we have square. Then if we take a -1, we will get positive, all positive, right? Because -1 times 5 with -5 plus 21 will be positive. The denominator will be positive, so we get all positive values for this, for 1 and the -1 and above. That's why we get this kind of graph, right? From a value a little bit bigger than -5, like -4.9, we'll have this part. We will have negative value. Then maybe we evaluate another value. Let's say -1 or -0.5. Right? We will get a value somewhere here. Let's say -1. If it's -1, we get -5 plus 21, 16. 16 divided by 16, we get a 1. We get a positive 1. So the graph goes up. So we get a positive 1. We get this point, right? Somewhere here. But this is a tricky one. This won't be easy to graph, this one, right? So this one is a little bit easier to graph. This one is a little bit tricky. We have to give a couple more points here because we have this, downward below y equals 0 and above y equals 0. And we can give a very big number to evaluate the function value, maybe like 100, right? Maybe let's say this number is 100. Then 100, that would be a very big number. 100 times 5. 100 may be too big. Let's do 10. So 10 times 5, 50, 71. Then we have 15 square. We see the number is a kind of small. It's less than 1, right? If now we add 0 to this, we have 521 as a numerator. But denominator, we have 100 plus 5 square. It's a 10,000 something. So this number, as x become bigger, the function value becomes smaller. So that's why we know the graph of this piece like this. So only in the middle of -5 to 0 is a little bit tricky. We have to give a couple more points. All right, so this is one kind. We see the numerator has lower degree than the denominator. The numerator is polynomial of 1 degree. The denominator is polynomial of 2 degree. So this is one kind. Let's see another kind. The numerator is a quadratic polynomial, polynomial degree 2. The denominator also polynomial degree 2. Let's put in a factor form. Let's put in a factor form. So x-intercept is -1 and 4. Y-intercept is -2 and 0, right? Not y. Y-intercept is we don't have y-intercept. You see this x in the denominator. We cannot set x equals 0, right? Because 0 is not in the domain. So 0 is not in the domain. Zero. We don't have y-intercept. So no y-intercept. Because if we put 0 in here, 2 times 0 will be 0. It causes the denominator to be 0. But if we do have vertical asymptotes, so set the denominator to be 0. So x equals 0 is the vertical asymptote. X equals -2 is not vertical asymptotes. What about horizontal asymptotes? Horizontal asymptotes, the leading term in the numerator is x squared. Leading term in the denominator is 2x squared. So the horizontal asymptote is half. Y equals to half. Y equals to half. All right, now let's see in between. So let's graph actually. So I have x equals to 0 and -2, right? So I have two vertical asymptotes. X equals to -2 and x equals to 0. Two vertical asymptotes. Now we have one horizontal asymptote, which is y equals to half. Once we have this, we can draw this dotted line. Draw the dotted line for x equals -2. Dotted line x equals 0, which is the y-axis. And the horizontal asymptote is a half, y equals a half. We'll draw this dotted line. And then we know our graph of those two branches, not the middle one, the outer one, the outside one will not cross this horizontal and vertical asymptotes, but the middle one could. So now let's use some points, right? We have interval from -infinity up to -2, from -2 up to 0, from 0 up to positive infinity. And also, we may evaluate x equals to maybe -1/2 and a half, right? So let's see here. So maybe we choose a value less than -3, -2. So here, maybe we choose -3. Then we evaluate -3 plus 1 negative, -3 minus 4 negative. The bottom will be negative, negative. Altogether will be positive. That means the y value is above x-axis. So that's why we have this branch. From -2 up to -infinity, we have this branch of the graph. Because when we evaluate, the y value is above the asymptote. The y value is positive, which means it's above the horizontal asymptote. Then we want to find a value very close to -2, but a little bit bigger than it. So maybe we use -1. Let's see if -1 works. -1, we will get 0, right? So we will get 0. That doesn't speak much. Let's use 1/2. Maybe let's use -4/3. 4/3, right? Let's use this one. If we evaluate, so -4/3 plus 1 is negative, -4 is negative, 2 times -4/3 negative, -4/3 plus 2 is positive, right? Then we get this one negative, so we get a y value. Get a y value down below the horizontal asymptotes. Maybe we choose a value very close to 0, a little bit less than 0, maybe -2/3. 1 over 10, something like that, right? Very close to it, because we want to find out what's going on around here. If we do that, we get a positive, negative, negative, positive. In the end, we get a positive. That means the graph in this interval is above y-axis, x-axis, or the horizontal asymptotes. So then, in the end, we want to find another value in the interval of 0 to positive infinity, maybe 1. Then we get a positive, negative, positive, positive, we get negative. That means the function value is below the horizontal asymptote. So we get this branch. All right. Okay, so this is about how to graph rational functions. Let me give you some example. I don't have time to talk. Right. So right, maybe you go over this example yourself. This example, the numerator has a higher degree. All right, the degree of the numerator is higher than the degree of the denominator. In the end, let's see the graph. So let's see this one. So this graph, you see the degree in the numerator is 2. Degree in the denominator is 1. So the degree in the numerator is higher. So we get these 2 branches. But for this one, I don't know which one to follow by that. Okay, anyway, let me leave you some homework to practice. Okay, so from 11 to 16, let's do 11, 15, 3. So homework. Oh, I didn't give you homework for this one already, did I? I see these lines here. Right, find all horizontal and vertical asymptotes. Oh, right, I already give you homework for this one. Yeah, I'm not going to give you more. Okay, so finish the homework. If I have finished, let me see. Maybe I'll give you a couple for graphing. Oh, yes. Okay, let's try this. So 65 to 71. Let's try to graph these functions, all right? What about these ones? Find the intercept asymptotes and sketch the graph. All right, let me choose a couple from here. So 1, 2, 3, 4. Let me choose 6 from here. 1, 2, 3, 4, 5, 6. Okay, let's do this 6. 1, 2, 3, 4, 5, 6. Okay, great. So this will be new homework. So homework 7. Homework 7, homework 6. So this is a new homework, all right? 53, 55, 57, 59, 61, 63, 65, 67, 69, 71. Okay, try to use the steps finding x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes to graph the function and a couple of points. All right, any questions? Homework 7. So 53 up to 71 odd number. Okay, any questions? If not, I see you on Friday. All right. Homework 1, 2, 6. Yes, it is homework 7. Homework 7. Homework 7, which 3.7. We're still in section 3.7. So 3.7, 53 up to 71, odd numbers only. All right, have a good day. See you on Friday.